Hey everyone, my name is Thomas, and I'll be doing a presentation about storage on Kubernetes today. So I am part of a core platform team at Mambu, where we mainly focus on networking, compute, and storage. I've been with Mambu for 1.5 years, and it's been quite a ride, like working with multiple cloud providers, making our application independent on whatever cloud you choose, and so on. So for today, or actually about Mambu. Mambu is a product company, a cloud banking technology provider that was launched in 2011 with ambition to bring banking technology into the digital age, to make it accessible, flexible, and ready for any market opportunity. We offer customers a modern banking engine that allows them to operate as a technology company rather than a bank or regular old bank. We serve both traditional banks and new financial startups. So in order to be successful in a dynamic field such as banking environment, our solution is built on composable banking principles. This means that we offer a series of independent services which can be combined to meet the needs of wide range of customers. When we launched at 2010, there were only 10 people. We grew organically during the years, and today we are a team of 700 Mambuvians, present in 11 locations worldwide. Now we are supporting 200 customers in over 65 countries, like N26, OakNorth, Tandem, Orange, ZestMoney, and so on. Every month we are adding more than 3.5 million of new end user accounts to our platform, with a total of 49 million up to date. So this is truly amazing. And by the way, we are hiring, so go check our open positions on our site. And the talk, I'll be answering your questions at the end of the session, so you can throw them in the chat so everybody could see them. Okay, so nobody wants to be this guy, right? So I had a hard task to give you a practical example how to run databases and other storage-dependent applications on Kubernetes. But as always, there's no single true answer. So we will do it with a little twist. Let's focus on storage replication instead of running newest, greatest NewSQL database or some cloud-native solution. It's relatively easy to run databases on Kubernetes these days. You just choose your flavor of cloud distributed database like CockroachDB, Yugabyte, NuoDB, Tib, Vitess, whatever, and call it a day. Problem is that storage provisioned by Kubernetes is bound to same AZ where pod is running. There are some solutions for it, but hey, we don't want to do vendor locking, right? However, I'll try to show another approach focusing not on database engine used, but on storage instead. In essence, if your storage with data is replicated across multiple availability zones, then it's possible to start another instance of your database on a copy of the data and have AZ fault tolerant set up that way. In this case, you need to rely on middle storage layer that could do replication for you. So there are some products on the market like Ceph, OpenEBS, Longhorn, BlastRFS, or Portworx. So I'll be using Portworx for this demo because of personal preference. But as I mentioned, any can be used like OpenEBS, Ceph, etc. So here's a diagram of Kubernetes cluster spanning 3 availability zones. Let's say I have a single pod that uses persistent storage and it's running on AZ2 in the middle. Since native persistent storage is AZ bound, in case of AZ2 failure, pod and all data would not be accessible. Using middle storage layer, persistent volume can be synchronously replicated. And in case of AZ failure, potential or identical pod can be spun up on another AZ, and it would be running on the copy of the data. So basically, with minimal loss or minimal downtime, you would be able to get your application up and running. So I'll show that in a demo a bit later. So caveats. So storage replication is not free. It adds latency to your application's response, where it needs to wait for data to be written on multiple disks on other AZs. So middle storage layer ensures strong consistency. Overall, rule of thumb, like total latency equals network latency multiplied by replica count. Cluster topology is also very important. So no node is too far apart, like from network perspective, because we need to have acknowledgement packets received, so we know that the data has been written. And yeah, and we need to use multiple AZs because using one doesn't work in this case. Same goes for regional replication. It can be used for, let's say, DR as well. If latency isn't too bad, that means generally it should be less than 10 milliseconds. If latency is larger, then asynchronous replication can be used, but that's another can of worms and subject for another day. So to sum up, it's slower, more expensive, but more resilient. And you may ask, well, does it make sense to run the storage replication on top or on the bottom of application replication? Let's say, I don't know, CockroachDB, which does application replication on the top. So, well, yeah, kind of, it makes. So imagine a scenario if you lost your pod and spun a new one on another AZ. It would be empty. It would not have any data on it. So that means it will need to sync the data depending on the data set that you have. It might take a considerably longer time. Imagine same scenario, you would spin a pod and you would have data available on the spot. All you would need to do is sync one small delta, like again, depending on your workloads, but it would be considerably faster, like minutes instead of hours. So as I mentioned, I'll be using Portworx for storage replication and Minayo as a demo app. Before you start shouting, yes, I know Minayo is not a database. I chose it just for ease of use and demo purposes. Think of it as object database. So if you're not familiar, Minayo is a high-performance object storage, like Amazon's S3. When running in distributed mode, it ensures that data is replicated on multiple drives, tolerating half of all servers or pods loss. And Portworx, it's a clustered block storage solution and provides a cloud-native layer from which containerized stateful applications programmably consume block, file, and object storage services directly through a scheduler. So you can add block storage provided by your cloud vendor to Portworx, and it will make sure you get logical volumes that are replicated and resilient. So for demo, let's see what happens with regular Google Kubernetes setup when we use middle storage layer. In case of failure, only pod is moved to another AZ, where a copy of data is already present. This results in recovery taking seconds instead of total loss of your application. So demo time. Let's hope demo gods are in a good mood. Yeah, also don't be frightened. I'll be using K8s CLI tool to interface with the cluster. So for me, it's way easier. Just learn a few shortcuts and you don't need to touch mouse ever again. And you don't need to type those tedious kubectl commands. Okay, let's get cracking. So as you see here, I have my cluster containing 3 nodes. Each node is in different availability zone. So we can see this one is in Europe West 1C, West 1D, and West 1B. I have few pods running here. Yeah. So the first one is the default application, like you do just do helm install. That's it. You're set. It provisions you a PVC and the persistent volume underneath. And the second one is a bit different. It uses Portworx storage class that I will show in a second. And it also uses another scheduler called Stork. So from PVC perspective, we can see that we are both 8 gigs, but the only difference is that we're using different storage classes. If you would go to the storage classes, this looks to be pretty normal, but the only difference is that it's using provisioner Portworx, and it has this parameter which says that each volume needs to have 2 copies of data. So if we look here, here is my Minayo interface. We have an object in it. If anybody is wondering what it is, so ta-da. Yeah, it's running, it's fine. Let's cordon the node that it's running on. DRXD cordon. Okay, this node is no longer allowed to schedule any pods. And let's kill that pod. Yeah, so as expected, we can see that pod is in a pending state because it doesn't have a place to be scheduled on. We don't have that node available to us. Therefore, if we check our reachable. Let's do the same with another pod, which has storage replicate. Keep it that node that's running on. It's DRDX. Boom. And the pod is already automatically scheduled on another node. We see it's in a running state. Boom. And it's healthy. So let's check. This is my second window. Yeah, application is reachable. I can reach my object. Good times. So this is just example of single pods, but if you're running databases or something else, you would probably have set up more similar to this, where you have multiple pods running on multiple availability zones or multiple nodes. So again, let's try this. This is Minayo running in distributed mode, but without storage replication. So let's uncordon the node that we have. So everything is available. And let's choose the worst possible scenario. Let's kill these pods because we're running on the same node. Cordon. Boom. Boom. Again, you lost half of your cluster. If you go to application, you can see it's running, though it's a lot slower. It's trying to retrieve that object. Yeah, so I have my storage. I'm not completely down, but there's one but. Because I lost half of my storage, I cannot add anything new to it. It just will not work. So I am in a read-only mode, and that might be not great depending on what you're using this for. So let's fix that. Let's uncordon the node. And let's get to another example. Yeah, as you can see, I've uncordoned the node. It immediately started scheduling those pods, and it will get running in few seconds. Even though on the application side, we don't really see it. We had error before, refresh. it's running. Let's try writing something to it. Yay, it worked. Okay, final example. So for running cluster with distributed storage with replication. So if we look at the PVCs, we're using an IO storage class. And again, let's choose the worst possible scenario. Let's kill these pods and see what happens for the cluster. So cordon done, and kill. And again, you can see that pods immediately have been rescheduled to another node. In this case, it's same as this guy. And pods already are running. It like took, what, 5 seconds to recover. If you look at the application, it's accessible. Of course, it needs to do sharding on top. Pick up the shards, gather all the information. Yeah. And no downtime, we can write other objects to it. So this is the basic example how we can utilize the storage replication. And scenarios are really, really broad, like you can use it for DR as well, given certain conditions. And again, it can be like additional layer if you really need resilience for your databases, despite the flavor you choose. Okay, so that's pretty much on the demo side. Please visit us at Mambu's virtual booth, where you can find out and take a small quiz and win a few vouchers. So thank you. I'm happy to answer questions if you have any. Guys?
Yes, we're here.
Good.
That was quick. I have to admit, that was quick, but effective, I would say. So, first question. Yes, we have question. How does Portworx compare to, you guys know better. I mean, how does that thing compare to the other thing?
Yeah, so first thing is a commercial product, which you need license to enable all its features. So it's apparently more developed and more robust. Ceph is more open sourced and it's still maturing. But if you're looking into alternatives, I would recommend you to have a look at OpenEBS. It's really interesting project with different path and yeah, it also needs some maturing, but also just keep an eye on it as an alternative.
Look, Thomas, since we have plenty of time till the end of your session, speaking of the DevOps world, from your perspective, you know, what are the things we should keep an eye on besides the Kubernetes? I mean, we could elaborate also on Kubernetes. So today you tackled the storage thing, okay? But what other things are very important from your perspective? And then beyond Kubernetes, what's relevant in your world, so to say, because you're the expert. I'm just showing off here, so I'm not into the DevOps, technical thing. I'm trying to learn from the best instead.
It might sound like a lot of buzzwords, but I think mentality and mindset is really important. So collaboration between teams and people working on a project. So that's the main thing. Technology, I think, comes second, but again, it's also important. So that's my short summary. If you want to expand, then yeah, I'm happy to.
Yeah. Let's expand. Let's expand because there is a lot happening in this space. I mean, people are trying beyond the mentality thing and so on. People are working quite a lot on tooling, and I don't know, the clouds are enabling this. What's under your radar besides Kubernetes? And the other question is, what does a site reliability guy do? So
Okay, so it's, I
number
guess,
one, number two. Okay.
okay,
So don't make
matter of perspective. Okay,
Mhm.
so for devs, it's really important to be to enable people or developers to do great stuff, to be like in between what's happening, let's say, on the old ops roles, like where actual servers are running, and what's happening with developers, how we're writing their code. Is it scalable? Does it work okay as a microservice? Is it easily configured with deployables, etc.? Monitoring and observability, all those things are still very valid. We need to gather metrics, gather feedback, know what your application is doing,
Yeah.
know and have an easy way to troubleshoot it. So in case of incident or emergency, or let's say customer complaint, you can always track what happened, and you're always on top of what, like, you're keeping the pulse basically.
I mean, how do you do that? What do you use, or how?
There are many tools, but I mean, it's more of a mindset. If you just lazy and you don't implement, let's say, metrics for your services, you'll basically blind. If you're having performance issues and you're saying, well, yeah, you'll just add more computing power to it. Well, you can do that, but it will cost you.
Yeah.
Maybe it's way easier to have some kind of APM, application monitoring solution installed and track your requests that way. So
Okay.
again, it's a mindset. You don't need to be lazy, like let's say some developers might be, or don't be focused just writing on a code. Have a broader perspective what your application is doing, what's it intended for, and how are your customers interacting with it. Like, for example, if you're having a spike of many customers, will your application be able to scale up or down? Will you crash or not? Will you be able to handle the load? So I guess this is important. And for number two, SREs, yeah, site reliability engineers, we are basically making sure or building the platform, like using Kubernetes and using, let's say, storage layer to build a resilient platform where we could have our applications running on. Of course, same principles, same DevOps principles apply. It needs to be scalable, it needs to have a feedback like monitoring logs, etc., alerting, etc. So I'd say these two things.
Okay. Thanks a lot. We've got another question. If it makes sense to have replication set for only one region, if the time to recover is only 5 seconds, unless you have multiple regions.
Yeah, again, there are many ways to skin the cat, but the main problem with cross-region replication is latency. So that adds up, that network latency adds up to your write time to the disk. And that might be really impactful sometimes, especially if you're like trying to span multiple regions. So in that case, it makes sense to have asynchronous replication, as I mentioned. And let's say with single region Kubernetes cluster, you're covering failure of one single AZ. And again, we know AZ is not the same data center. It's like spread apart, multiple kilometers, different power and data inputs, etc. But if we really want to use another region, we can do that. And if that region is, let's say, far apart, like at the other end of the world, we can use asynchronous replication where we don't have data consistently streaming to another data center, but it's written in chunks, let's say every minute. And that way you can have that resiliency. Of course, that would mean in case of DR, you need to do like full redirect to another cluster, and you might have some downtime. It's not too robust, but in this case, you can make sure that you have pretty good RPO.
Okay, thank you. There's a thumb up coming from the. Yay, good job. I've got another one. I would be very, very interested to learn from you about the following thing. So you're running your stuff on Amazon, right? On AWS.
Not necessary. We're using multiple clouds.
Okay, but let's
Right.
take for my benefit, for my personal
Sure.
benefit, let's stick with AWS. So how do you organize the work in terms of, I don't know, maybe organizations, accounts? You've got the dev teams. Do you have sandboxes? How do you manage costs? How do people experiment on new stuff? How do you handle this thing?
Yeah,
Because
it's a
speaking of
good question.
DevOps, in many situations there is a DevOps guy there who said, "Well, I will do it for you," but you
Yeah, it's
don't know as a developer what to request because yeah, I'm clicking on something, creating a service, but that's built on top of other underlying services. Okay, you discover that, you come back to me and said, "Well, this doesn't work. You need to, I don't know, enable some networking or security, whatever. Give me some other privileges." And so,
yes. I guess the goal is to have a single button provisioning where everybody could spin up a new environment on demand. And same would go. Let's say you have a merge request incoming, you want to test it. So as part of a pipeline, you could have an environment provisioned. You could have your code built and deployed on the cluster. You could have some tests ran. And that way you would know if your stuff is really working. And only then you could merge it to master. So that's an ideal scenario, which we are still aiming for. We are not there. Don't get me wrong. There's like no silver lining or silver bullet. But I guess if mindset is there and at least the idea is there, we'll be able to do it.
so what you're saying is that not every developer has his or own account in Amazon and in AWS, sorry, right?
Yeah, like developers should not need to know Amazon or anything. It should be all in a pipeline. So you're writing your code, and then magic happens. It automatically gets tested on the same environment that, let's say, production is running.
Okay, and if someone needs to use like a new service, new compared to what they've used previously in the architecture, what do they do?
Yeah, so I guess that's the DevOps guy that you would call, which was a bit developer, bit ops person.
But again, the DevOps guy is your friend until he's not, because then he gets back to you and says, "Well, this is not running as you would expect." I mean, how do you experiment? Where do you experiment if you're a dev? Do you buy your own account or what do you do?
No, of course.
Do you have like a sandbox?
The access is provided. Like you get access to the dev account, and you can do more or less whatever you want. You can play experiments, try new things. It's totally fine. Like it's not a bad thing. But I mean, from day-to-day operations, you shouldn't be really concerned about.
Absolutely. Operations, no way, of course. But in the initial phases, yeah, you need a sandbox. You need privileges to do your stuff before a DevOps person can automate everything and then so on. Yeah.
Yeah, that's true. So
Good. Good.